All right, let's talk about the ellipse. So number 3, complete the square to write the equation of the ellipse in standard form. Then identify the center, vertices, foci, and eccentricity, and then graph the ellipse. So let's just work through this one. So again, notice we have an x squared and a y squared, which means this is an ellipse or a circle in this case that we've been working on. So I'm going to put the x's by each other. Notice there's not another x, which just means I don't have to complete the square with the x's. That one actually is very convenient. So I'm just going to line up my y squareds, which they were already kind of by each other, and I'm going to move that 245 to the other side so it becomes positive on the right side of the equation. From there, again, the 9x squared is just going to keep coming down, but we need to pull this 49 out. So we're going to have 49, and we get y squared. Now if you take 196 and divide out the 49, you're just left with 4y. And then we still have equals 245. Then we complete the square, so we take half that middle term. That adds 4 there. Now notice you have that greatest common factor out front. So again, 4 times 49 was 196. So we need to make sure that we add 196 onto the right side. Now again, the 9x squared just keeps coming down, and then we factor the y part. So we have y plus 2 quantity squared is equal to, we take 245 and we add 196, and it looks like we end up with a 441. Oh, that's a 4. Now, we need this to be equal to 1, right? So we take this and we say, well, let's divide everything by 441. So we divide all the terms by 441. Now notice the coefficients always simplify. That's how you know if you're simplifying it correctly. So if I divide 9 into 9, right, that goes in once. And if I take 441 and divide it by 9, it goes in 49 times. So essentially this is going to be x squared over 49. Okay. Then 49 goes into 49 once, and we just found out that it goes into 441 9 times. So this one is going to look like y plus 2 squared over 9 is equal to 1. This is our standard form of the ellipse. Now we talked about the values on the bottom tell us a little bit about the ellipse. So we first look at this guy, and this is the biggest number, right? So that has to be like our a squared. And also, because it's under the x value, that means the longest axis, that major axis, is going horizontally. So it's going to be a horizontal parabola where a is equal to 7. Okay, we know over here this is our b squared value. So we know that the minor axis, right, is going to be equal to 3, or that b value is 3, because the minor axis is 9. So we take that, and I guess we could go ahead and graph it and then find the other parts. So again, you need your center to graph this, and your center comes from your HK values, just like a circle center. So we know that the center, and again, it didn't ask me, oh, it did ask me to find it. I knew that. Okay, the center here is going to be 0, because there's nothing added or subtracted from that x, and then negative 2. So I'm going to go over here, 0, negative 2. There's the center of my ellipse. And I know that the a value is 7, so that means it's going to go 7 units in the horizontal direction from my center. So 1, 2, 3, 4, 5, 6, 7 is one of the vertices. 1, 2, 3, 4, 5, 6, 7 is another vertice. And then we go 3 units in the vertical direction, because our b value is equal to 3. Again, then you do the best you can to draw this. Oh man. Awesome ellipse here. Okay. And then from there, we were asked to find the vertices. So if you want to find them just from your picture, again, this is horizontal. So really we're just adding them to our h value. And we would be adding 7. So you'll notice on your graph, your vertices are out at -7, -2, and +7, -2. So it would look like that. Then we want to write the foci, and then the eccentricity. So remember that the foci, okay, I almost spelled that right. You need the c value, and we know that the c value represents the distance from the focus to the center, and we find that by doing c squared is equal to a squared minus b squared. So we don't know what c squared is, but we know that a squared, right, is 49, and b squared was 9. So c squared is actually equal to 40, and when we square root both sides, we get c is equal to the square root of 40. You can leave it as the square root of 40. Generally, we would simplify that. So if we build that tree, there's a 4 and a 10, and that leaves us with 2 square root of 10 because we'd have a group of 2's. So remember, to find that foci, we take whatever our h value is, right? We plus or minus that 2 root 10, and then our value, it's all moving along this -2 line, so that's never going to change. So we would come up here and we would say that our foci was 2 square root 10, -2, and -2 square root 10, -2. Okay, and then again, the eccentricity is going to be equal to c over a. So our a value again was 7, so we're looking at something like that. Okay, I'm going to make a new video for number 4.